Good day everyone, welcome back to Winner's Class, and in this video I am going to discuss to you the ways of expressing concentration of solutions. Now, what is concentration? Concentration is the measure of the amount of a substance present in a mixture, or in a more specific manner, it is a measure of the amount of solute that has been dissolved in a given amount of solvent or solution. Now, there are different types of concentration of solution. We have the percent by mass, percent by volume, mole fraction, molarity, molality, normality, parts per million or the ppm, and parts per billion or the ppb. Of course, we are going to discuss each one of them, but first, let us discuss the percent by mass. So what is percent by mass? It is the ratio of the mass of the solute to the mass of the solution multiplied by 100%. I repeat, it is the ratio of the mass of the solute to the mass of the solution multiplied by 100%. Now, let's express this in mathematical expression. Percent by mass is equal to the mass of the solute divided by the mass of solute plus the mass of solvent times 100%. Now, we can still simplify this formula. Since solution is a combination of the solute and the solvent, this expression here, we can simplify it into a single term, which is the mass of solution. Now, let's rewrite this formula, and this will become percent by mass is equal to the mass of solute, or the M solute, divided by M solution, or the mass of the whole solution, times 100%. So this is now our final formula that we're going to use in different computations. The percent by mass is unitless. Why? Because it's just the ratio of two similar quantities, which is mass. So let's have our first example. A sample of 0.892 grams of potassium chloride, or KCl, is dissolved in 54.6 grams of water. What is the percent by mass of KCl in the solution? For us to solve this easier, it is very important to identify first the given. So we have the mass of solute as 0.892 grams. We also have the mass of the solvent as 54.6 grams. Now, what about the mass of solution? So we all know that mass of solution is equal to the mass of the solute plus the mass of the solvent. So this will become 0.892 grams plus 54.6 grams, and the final mass of the solution is 55.492 grams. Okay, so we have now the complete given, and we can substitute it into our formula, which is percent by mass is equal to M solute divided by M solution, or the mass of the solution, times 100%. So the mass of the solute is equivalent to 0.892 grams divided by the mass of the solution, which is 55.492 grams, times 100%, and 0.892 divided by 55.492 is equivalent to 0.0161 times 100%. And the final percent by mass of the solute, or of the solution, is 1.61%, because 0.161 times 100 is equivalent to 1.61%. So this is our final percent by mass of the solution. So let's have an example number 2. Calculate the amount of water in grams that must be added to 5 grams of urea in the preparation of a 16.2% by mass solution. This is different from the first problem because what is asked here is the mass of the solvent or the mass of the water. So let's identify first the given. The mass of solute is 5.0 grams. The mass of solvent is unknown, and the percent by mass that is given is 16.2%. So how are we going to solve this one? Let's write first our formula. Percent by mass is equal to mass of solute divided by mass of the solute plus mass of solvent. Times 100%. Now let's derive this formula. To do that, let's cross multiply the values. So let's multiply percent by mass with the mass of solute plus the mass of solvent. So we will have percent by mass times m solute plus m solvent is equal to the mass of solute times 100%. Now, using the distributive property of addition, let's multiply or let's simplify the first expression. So we will have percent by mass times m solute plus, again, let's multiply percent by mass with the mass of solvent. This will become percent by mass times m solvent equals m solute times 100%. So we can still simplify this value. To do that, let's move the percent by mass times the m solute to the other side. So we will have percent by mass times m solvent is equal to the quantity m solute times 100% minus percent by mass times m solute. So this is not our final formula. Still, we can simplify this one and let us divide both sides by the percent by mass. This is now the division property of equality. So we will have, or let's divide percent by mass both sides. So we could cancel the percent by mass on the left side. So we'll have m solvent is equivalent to m solute times 100% minus percent by mass times the m solute or the mass of the solute divided by the percent by mass. So we will have, or we now have, the formula that we're going to use to solve for the mass of the solvent or the grams of the water. Now let's supply the given into our formula. So let's write again the given here. We have m of the solute is equal to 5.0 grams while the percent by mass is equivalent to 16.2%. Now let's apply the given into the formula. We will have the mass of solute is 5.0 grams times 100% minus the percent by mass is 16.2% times, we have the mass of solute again, which is 5.0 grams divided by the percent by mass, which is 16.2%. Now what is 5 times 100%? We will have 500 grams percent minus 16.2% times 5.0 grams. We'll have 81% or 81 grams percent divided by 16.2%. So 500 minus 81, we will have 419 grams percent divided by 16.2%. So we will cancel the unit of percent here, and our final answer will become 25.86 grams. So this will be our M solvent. Now let's check if 25.86 grams of water will give us a 16.2% biomass of the urea in water. So let's go back to our first formula, which is percent biomass is equivalent to M solute divided by M solute plus M solvent times 100%. So the mass of the solute again is 5.0 grams divided by the mass of solute plus the mass of solvent. So we have 5.0 grams plus 25.86 grams times 100%. So we will have 5 grams divided by 30.86 grams times 100%, and this will give us 16.2%. So the mass of the solvent, that is 25.86 grams, is correct. Now I hope that you understand how to compute for the percent biomass of the solute in the given solution.